and welcome everybody at our Bauhaus Luftfahrt booth at ILA. Also welcome to everybody in the live stream and thank you for joining in. My name is Katrin Ebner and I'm the Strategic Research Coordinator of Hybrid Electric and Hydrogen Aviation at Bauhaus Luftfahrt. And today I want to talk to you about some key learnings out of more than 10 years of hybrid electric aviation research. So first, let's talk about the initial motivation for electrification. Well, basically, electrical energy transmission and also storage comes with high efficiency. Furthermore, it enables distributed propulsion concepts, and also the energy stored in the battery comes with zero in-flight emissions. So at Bauhaus Luftfahrt, we always try to understand what can be the impact of such concepts on the overall emissions of aviation. And as we can see here in this chart, actually, most of the emissions come from larger segments. So for us, the question is important: to what extent can we translate these benefits of electrification to larger concepts? And if we look at those arguments, basically we should electrify everything, but of course electrification also comes with its drawbacks, especially high component weight. So for larger aircraft concepts, oftentimes battery hybrid electric concepts were investigated. So basically, when we look at this here, we already see that there is quite a large landscape of different hybrid electric architectures to be explored. And while I don't want to go into detail into every single one of them, but we can have discussions about that later, of course, I want to point out that there is really a vast design space. One can exploit electrical nodes, one can exploit mechanical nodes, and this, of course, comes with a lot of opportunities, but also with a lot of challenges. So as this assessment, due to this huge design space, is rather complex, while we have quite a good understanding already of propulsion-related aspects, really exploiting aerodynamic benefits comes with understanding aeropropulsive considerations, and here for integrated assessments we still have quite some limited availability. So just a brief look at the timeline. Within the last 10 years, quite a number of hybrid electric concepts and also electric concepts have been investigated, and this is really only a few of them, out of which of course the Bauhaus Luftfahrt Sealiner or the EMOTEP concept. And we basically took a look at all of these studies and many more out of the last 10 years of hybrid electric aviation research and tried to understand again what is the impact on larger aircraft with transport tasks for more than 50 passengers or more than 500 nautical miles. So our first key learning is, well, this task actually comes with quite a lot of practical challenges. So first of all, as mentioned before, due to this huge design space, the investigation of hybrid electric architectures is quite complex. Also, this modeling complexity doesn't really help us, let's say, to really exploit all the benefits that were theoretically possible. Also, in comparing all of the different studies, we can see that basically the assumptions for the different technological components vary drastically. So in some cases, really a drastic development of these components would be necessary to actually match what has been assumed for the studies. Also, there are some challenges related to the actual realization, like how can we dissipate all the low temperature waste heat, and also certification perspective is in parts unclear. Also, distributed electric propulsion, as is talked about a lot in this context, does come with some benefits, but these benefits are not universal and cannot be extended to all aircraft concepts. So for example, when we look at the left side here, when we talk about blown wing concepts, lift is increased. However, it can also come with drawbacks like increased component weight or also a lower propulsion efficiency due to inflow distortion. Similarly, for wingtip propellers, while there are some aerodynamic benefits associated, there are also other drawbacks like, again, enhanced component weight, etc. So basically, even though promoted quite a bit, we could not really find a universal benefit of distributed electric propulsion concepts. I apologize, the presentation is jumping. So next key learning, and this is really a critical one, the potential of all the different hybrid electric concepts that were investigated in this number of studies that mentioned before is strongly tied to the battery performance. And this really limits the range capability of such concepts. So as we can see in this chart on the bottom left side, there is basically a correlation drawn between the battery pack specific energy in watt-hours per kilogram and the delta fuel burn that was found in the different studies. And as you can see for the transport task that we are interested in, so basically the blue bubble on the chart, battery pack specific energies of around, let's say, 600 to 700 watt-hours per kilogram were assumed to actually yield a positive impact, in this case a negative delta fuel burn. And this, I want to point out, these numbers relate to the battery pack. So when we look at the graph at the right-hand side, we can see that if we want to have a pack with that energy level, we need to start really optimizing the material level and have, by a certain factor, higher energy densities in the material level itself, and then packaging is added, etc. And we have a reduction of the specific energy on pack level. So basically, taking into account these cell-to-pack factors, we can see that basically for the transportation task that we are discussing, there are battery requirements significantly higher than what is currently demonstrated. The demonstrated parts you can see in the dots. But some forecasts, though, match these requirements. However, when we further take into account, for example, aging properties, or also, for example, cyclability, etc., maximum depth of charge, then we end up at significantly higher requirements than what is actually currently projected. So, to give you a quick summary, first of all, while there are theoretical benefits of electrification, really exploit all aero propulsive benefits as there is a vast design space and analysis is complex. Also, as we have seen, especially in the last few slides about battery performance, the benefits are strongly range limited, especially for larger aircraft. And as noted before, current battery performance and even forecasted battery performance is insufficient for the transportation task noted, so higher than 50 passengers and also more than 500 nautical miles. You may wonder what is the good news in this presentation. Well, I want to point out that, of course, electrical concept and also hybrid electric concept are still on for smaller aircraft. And with this, I want to thank you and ask if there are maybe any questions. Questions can, of course, also come later at any time today. You can find me at the Bauhaus Luftfahrt booth. Thank you.